A particle is acted on by forces of I plus 4j minus k newtons, I plus 10j minus 3k newtons, and 6i plus 10k newtons. Work out the resultant force R. So the resultant force is the total force. So we're going to need to add all of these forces together. So let's write them as columns. So the first one, we've got 1 in the I direction, 4 in the J, and -1 in the K. The second one, we've got 1, 10, -3. And the last one, we've got 6 in the I, we've got 0 in the J, and 10 in the K. So add them all up, we have 8, 14, 6. So the resultant force is 8I plus 14J plus 6K. Find the magnitude of the resultant force. Whenever we're finding the magnitude, that's just the length of the line. It's Pythagoras. So that will be the square root of 8 squared plus 14 squared plus 6 squared. And we can just type them into the calculator. And we get 2 root 74. So 2 root 74 newtons. One for you to try, see if you can give it a go. So we're working out the resultant force, so add all the forces together. The first one, we've got 3, -2, 0. We've got no k's. The second one is 3, 1, -5. And the third one is 2, 6, -1. So add them all together, we get 8 in the i's. We have -2 plus 7, so that's 5 in the j's, and -6 in the k's. So we've got 8i plus 5j minus 6k newtons. The magnitude, Pythagoras. So the square root of 8 squared plus 5 squared plus 6 squared is 5 root 5. So it's 5 square root 5 newtons. A particle of mass 2 kilograms is acted on by a force of 4i plus 5j minus 2k newtons. Find the acceleration. We can use F equals ma. So the force is the mass times the acceleration. F equals ma. So F is 4i plus 5j minus 2k. And that equals the mass, 2, times the acceleration. So to get acceleration, we just need to divide by 2. So the acceleration is 2i plus 5 over 2j minus k. And that'll be in meters per second squared. So acceleration is meters per second squared. That's because a newton is a kilogram meter per second squared. Find the magnitude of the acceleration. So again, the magnitude, just give it as a number. So how long is that line? If it was 2i plus 5 over 2j minus k, Pythagoras. So 2 squared plus 2.5 squared plus 1 squared, all square rooted. And we get 3 over 2 square root 5. So 3 over 2 square root 5 meters per second squared. One for you to try. Give it a go. So again, we've got force and we've got mass. We can find acceleration using force equals mass times acceleration. So 6, -9, 2. equals 3a. Divide by 3. So the acceleration is 2 negative 3 2/3, which is 2i minus 3j plus 2/3 k meters per second squared. The magnitude, we use Pythagoras. So the square root of 2 squared plus 3 squared. The signs don't matter if we're squaring, because negative 3 squared and 3 squared give 9. Plus 2/3 squared, all square rooted. So the square root of 2 squared plus 3 squared plus 2/3 squared is 11/3 meters per second squared. A particle of mass 3 kilograms, initially at rest, is acted on by a force 8i minus 6j minus 2k newtons. Part A, find the acceleration. So again, F equals ma. So our force, 8i minus 6j minus 2k, equals the mass, which is 3 times the acceleration. So to get acceleration, we just divide by 3. 8/3 I minus 2j minus 2/3 k meters per second squared. Part B, find the distance. So it's distance, not displacement. So we want just a number. We don't want something in i's, j's and k's. Travelled in 5 seconds. So we're going to use SUVAT. S-U-V-A-T. S is our displacement. That's what we're working out. U is the initial velocity. And it was initially at rest, which makes U 0. V, we don't know. The acceleration is 8/3 I minus 2j minus 2/3 k. And the time is 5 seconds. Now, it's going to be easier to find the magnitude of the acceleration before we do our calculation. And we only want distance. So we don't want displacement. If we wanted displacement, we would leave our answer in terms of i's and j's and k's. But we can find the magnitude. So the magnitude of the acceleration is the square root of 8/3 squared plus 2 squared plus 2/3 squared. Again, the signs don't matter because we're squaring them. So 2 root 26 over 3. So we'll use that. 2 square root 26 over 3. We'll use that as our acceleration in our calculation, which will make it a lot simpler. And our formula that we're using is the one without v in it, which is S equals ut plus half at squared. So the displacement is u times t, which is 0. 0 times 5 is 0, plus half times the acceleration, 2 root 26 over 3, times t squared times 5 squared. So it's half times the answer times 5 squared, 25 root 26 over 3, or to 3 significant figures, 42.5. So 42.5 meters. One for you to try. See if you can give it a go. So we have a particle, 10 kilograms, initially at rest again, acted on by a force. Find the acceleration. So F equals ma. Force equals mass times acceleration. So 9i minus j minus 2k equals 10 times acceleration, divide by 10. So we've got 0.9 I minus 0.1 J minus 0.2 K meters per second squared. Find the distance travelled in 10 seconds. Let's find the magnitude of the acceleration. So the square root of 0.9 squared plus 0.1 squared plus 0.2 squared is root 86 over 10. I'll leave that for now. And then we're going to do suvat again. So we want to know the distance. We don't know the final velocity, but we know acceleration and we know time. So again, S equals ut plus half at squared. U times t, 0 times 10 is 0. So S equals half times root 86 over 10 times 10 squared and we get 5 root 86 or 46.4. So 46.4 meters.